Okay, here we go. In this lesson, we're going to determine the inverse of a quadratic function. First, let's review. We've done inverses before, but let's review how to graphically find an inverse. So over on the graph, I already have sketched this function, function f, which is negative x squared minus 2x plus 3. So what is an inverse? If you remind yourself, an inverse, in its simplest explanation, is you are switching the x and y coordinates. You're inverting them. So when we're doing it graphically, let's just make a quick little table here of some of the points that are on this graph, right? So this will be our function f of x. All right, so for example, let's see. Let's start with the vertex here, right? Right there's the vertex at negative 1, 4. So let's put that in the middle, negative 1, 4. We got a couple more points here. We got negative 2, 3, and 0, 3. Negative 2, 3, and 0, 3. And just to make it really accurate, let's find a couple more points. It looks like might be a little bit off, actually. And just because we don't have time, I'm going to say it's approximately. I just want to move quick here. Negative 4, negative 6. You know, because I'm not exactly sure. Oh, wait, I'm skipping some points here. Of course. Negative 3 over 0. Oops, negative 3 over, oh boy, I'm making a mess. Negative 3 over 0 up and 1 over 0 up. Obviously not moving as quick as we could here. Making mistakes, got to slow down. And I think we're a little bit off, but let's see. Where's negative 4? Actually, there we go. I think negative 4 might be a bit off, but let's go with negative 4 is at negative 5. And over here, we'll say 2 is at negative 5. And I'm not sure if that's exactly. Let me 1, 2, 3, 4, 5. Yeah, okay, so that's where they would be. So there's a table of points. All right, so to draw the inverse, remember we use the little minus 1 to denote that it's the inverse. All we're going to do is just invert or switch the x and y coordinates. So instead of negative 4, negative 5, it's negative 5, negative 4. Let's go put that on the graph, negative 5, negative 4. So this part's pretty boring. It should be very simple to do an inverse, right? Instead of negative 3, 0, it's 0, negative 3. It just literally takes time to do a neat job. So negative 2, 3, it's 3, negative 2. 3, negative 2 is right here. Here's our vertex. We're going to switch it around, make it 4, negative 1. Okay, and then we're going to switch this. So I'm just switching around. 3, 0, 0, 1. All right, and then finally negative 5, 2. All right, and there is my inverse. And I'm just going to draw the best parabola I can here. Try to make sure I actually go through those points. All right, so there you go. There's the inverse, right? Now, if we're going to label these on our graph, I'd put at the end of this one, f minus 1 of x. Now, remember, f of x just represents the y coordinate. And this one's f of x. So we have f inverse of x and f of x. All right, there's our two graphs. Another thing to remind you about inverses is this. You can draw a line going diagonally right through the graph, and it basically from one corner to the next like this, and it's always the same line, and I'm having trouble getting it where I want it to be here. I'm off by a little bit. There we go. That line, I'll just label it up here as y equals negative, oops, y equals negative x, y equals x. Sorry, I'm burning out from doing so many videos. Y equals x. That line acts like a mirror. Notice how everything on this side of the line matches up with everything on that side of the line. It creates that mirror effect, okay? All right, so there we go. We've drawn an inverse. That's very simple, right? Let's state the domain and range because we want to remind ourselves how domain and range work. Okay, so let's look at our original one, the one that was drawn in blue. All right, so I'm going to write f of x here for my domain and range. All right, so my domain, I'm just going to use d for domain, r for range. We're just going to look at the condition, right? But if we wanted to write it in full, you know, it would be x as an element of r such that, you know, and then y as an element of r such that. But in this case, domain can be anything. So all we're going to write is x can be anything, right? Think about this parabola. As it goes to the left and right forever, this one in blue, right? It's going to go down forever, right? And it's going to keep moving to the left and right forever. Or not so much moving, but we're going to have coordinates that exist. All right, the range on this one, y has to be less than or equal to 4 because that's the highest, right? You have a maximum here. All right, now, as far as the inverse goes, if you invert the x and y coordinates, you also invert the domain and range. So this one's domain is now going to be x is less than or equal to 4. Look at our x coordinates over here. Aren't they less than or equal to 4? Everything is on this side of 4. And the range, now y can be anything. All right, so pretty easy. I just swapped them. I don't even have to look at the graph to figure it out. Now, is f inverse a function? That's the one I drew in green, the one I actually drew on the graph. Is it a function? The answer is no. Why? Because it fails the vertical line test. Remember that if we draw a vertical line anywhere on the graph, and if it hits more than one point, so like this green one here, right? If it hits more than one point, which it does all over the place, it's no longer a function. So therefore, f of x is a function, f inverse of x is not a function. Okay, so that's the first thing we want to get out of the way. All right, let's move on, and we're actually going to find some inverses algebraically, and we're going to talk about the idea of looking at this green one here, right? If it's not a function, but what if we cut it in half? What if we cut it into two separate functions? The top half could be a function, and the bottom half could be a function, and that would make them both functions. So that's what basically we're going to do. What if we take the equation and we chop it into two separate equations? All right, so let's try that out. Okay, in this case, we're going to graph a parabola. So let's identify, looking at this parabola I gave you here, f of x equals 2x, 2 times the quantity x minus 3 squared plus 4. So this is in vertex form. So a would be 2, h would be 3, k would be 4. If you need help on that, go back, look at our old videos on all that, okay? So what's the vertex to this one? The vertex, this is in vertex form, so our vertex, right, is 3, 4. You know what? I'm going to make a little change here to this question just so it fits easier on the graph as I'm thinking this through. Instead of a 4, let's make this a 1, okay? So now let's make our vertex 3, 1. So I'm changing the question up just so it fits a little nicer on the graph. Okay, so 3 over, 1 up. We're going to put our vertex right there instead. All right, so let's make ourselves a little table of values here, right? X and y for f of x. Now, before we get going with that, the one thing you'll notice is there's a condition. This condition says x has to be greater than or equal to 3. Now, I've placed this condition on this parabola. This is no coincidence that there's x is greater than or equal to 3 and the x value of our vertex is 3. In other words, this is a half parabola, right? I'm starting at the vertex, and I only want to move to the right. I only want numbers that are greater than or equal to 3. I can't spell. All right. So this is going to give us a half parabola, right? Because I'm telling you to only pick numbers greater than or equal to 3. And if 3 is our vertex, there you go. All right, so we're going to start at 3, and we already know 3, 1. Let's try substituting in 4. So 4 minus 3 squared times 2 plus 1, you do all that, you're going to get out 3. So 4 over 3 up. Now, if you remember the little shortcut I showed you on graphing in one of the previous lessons, you can even do it a little quicker. Let's substitute in 5, and that should be enough. All right, so we'll sub in 5. 5 minus 3 is 2. 2 squared times 2 plus 1, and we get out 9. All right, there we go. I did that. That's why I changed that 4 to a 1 so we could fit some more points on. Okay, so this is just half a parabola. Now, if there was no condition, I could draw the other half like this, right? Here's where the other half would be. It would look like this. But I've put that condition on, right? So we don't want that. Let's just get rid of it. So this is a half parabola. This is f of x. All right. Well, why don't we start by, let's state the domain and range here first, and then we'll move on and check the rest here. So the domain of x, I'm just going to write it below here. X again. Now, in this case, x can't be anything. I was almost going to say x can be any number, but we've been given a restriction over here, right, on our domain. Our domain are our possible x values. So in this case, they're telling us, nope, x has to be greater than or equal to 3. So we do have a restriction this time. It was given in the question. What about your y values? The condition on your y's are they can be anything greater than or equal to the lowest it goes. Well, the lowest it goes, according to our table and our graph, is 1. All right, so now let's try drawing the inverse. So I'm going to draw the inverse in green here. And we'll put a little -1 on it. All right, so all we got to do to draw the inverse again is just switch our coordinates. So here's x and y. We're just going to switch them. It's going to be 1, 3, 9, and 3, 4, 5. And before I even draw it, I already know I can swap my domain and range. So now it's going to be x is greater than or equal to 1, and y is greater than or equal to 3. So let's draw and see what that looks like. 1 over 3 up is right here. 3 over 4 up is right here. And 9 over 5 up is right there. All right, so there's our inverse half parabola. So like I was talking about before, we're only drawing a half parabola this time because we're interested in just keeping it a function, right? If I had drawn in the other half, it would look like this. So I'm going to draw on what it would look like, right? So that would be the full inverse of the parabola, a full parabola if we took away the condition, but it's no longer a function. So what we're going to do is instead, let's just look at half a parabola because that's a really common question in math. All right, so now we have two halves of parabola, the original function and the inverse function. Now, the main thing of this lesson is you should already know how to find inverses. We've done that. We should already know how to graph parabolas. That's old news. We need to be able to find the equation of the inverse. And this isn't anything that's really brand new either, because we've done inverses at the start of the year. So let's write out our equation here. So I'm going to take the equation here. Instead of f of x, though, I'm going to write y so we can review how to exactly do this. So here we go. I'm going to write down y equals 2 times x minus 3 squared plus 1. Okay, so how do we find the inverse? There's really just one key to finding the inverse, and if you remember, we have to swap the x and y, just like we swap the coordinates over here, right? So we're going to swap x and y. So now it's x equals 2 times the quantity y minus 3 squared plus 1. All right, so now your job is to isolate the y, right? And this is the inverse. You're looking at it now, but to really write it in function form, we need to isolate the y. So let's ask ourselves, when you're doing this, for those of you that have some trouble with this kind of stuff, ask yourself, what's the normal order of bed mass order of operations that's going on here to y? That's the thing we want to isolate. So I'm going to write them down here. You don't have to do this in your homework, but let's think about it. What's the first thing happening to y? You're subtracting 3, right? So number 1. You're subtracting 3. I'm just going to write a little minus 3. What's the second thing that's happening? You go y, then you subtract 3, then you square it, right? So I'm just going to write square here. All right, what's the third thing that's happening? Y minus 3, then you square it. Then wouldn't you times it by 2 out front if you're following normal order of operations? So I'm going to write multiply by 2. And then the very last thing is you would add 1. All right, when you're finding an inverse, you want to undo all those operations. You want to invert them. You want to do basically the reverse of them, or more correctly, the inverse of them. Okay, so I'll do it step by step. And what's it going to look like? So we want to do the opposite of these 4 steps in the opposite order. So starting at the bottom, what's the opposite of adding 1? We're going to subtract 1 from both sides. So now I have x minus 1 equals 2 times y minus 3 squared. All right, so we did that. What's the opposite of multiplying by 2? We're going to divide both sides by 2. So I divide this side by 2, it's gone, right? Divide by 2, it cancels out. Divide this side by 2. Great. So now all that's left is x minus 1 divided by 2 equals y minus 3 squared. All right, next, we want to deal with the square. How do we get rid of a square? We do the inverse, square root. So I'm going to square root both sides. So I'm going to do the square root of this side, and don't forget to put the plus minus in front. X minus 1 squared. And when I square root this side, it's going to cancel out that square, and I have y minus 3. Now, I know I'm running out of room here, so I'm just going to bring this up here. All right, now what's the last thing? The opposite of subtracting 3 is to add 3. So I'm going to add 3 to get rid of that minus 3 there. I'm going to add it to the other side, and I'm just going to flip this thing around here. Y equals 3 plus or minus the square root of x minus 1 divided by 2. Now just to be clear, now I'm looking at my work, I'm going too fast. This is sloppy over here, what I did. See this right here? That square root is supposed to cover the entire fraction. I only covered the top. And I know it's almost covering the bottom, but let's be clear. That's a real big no-no in math. We want to make sure we're very clear that this covers the entire fraction, okay? All right, so there we go. So now let's write in function form. So we're going to go back, just like at the start, we replaced the f of x with y. Let's replace the y with the function name. And now that's the inverse, we write f minus 1. So this would be the inverse. Now, plus or minus, that is the question. Do we keep them both, or do we keep only one of them? Look at your graph, right? This represents your y coordinate, right? The f of x, so your y's, right? Let me write this in a different color here. These are your y's. So your y's start at 3, and then you're either adding to 3 or subtracting from 3. This is going to give us some numbers, right? Depending on what we substitute in x. 0, 1, 2, 3, right? So you're going to start at 3. Notice how that's the same 3 as our inverse right here. Isn't that our starting point, which is 1 over 3 up? Notice how y starts at 3. Well, all the numbers that are above 3 come about when you add to 3. So look, we're adding to 3. That would be the top half of the parabola. All the numbers that you subtract from 3 will give you the bottom half of the parabola, which we don't have. So when we want to decide whether we keep the top or we keep the bottom, right? In this case, we're keeping the top, so we want to keep the plus. So what we actually want to get rid of here is the minus. So we should really only have 3 plus. Now I can tell that in a bunch of different places. I can tell it by looking at my graph. I can also tell it by looking at my table of values. Look here. The y coordinates, right? Oops, I'm making a mess here. The y coordinates have to be greater than or equal to 3. well, how am I going to get y coordinates that are greater than or equal to 3 if I'm subtracting from 3? So that's why I got rid of the minus, right? We don't want the minus. We're only looking at half a parabola. Where else can we spot it? You could spot it from the very start because the x coordinates have to be greater than 3. So when you find the inverse, that means your y coordinates have to be greater than or equal to 3. So that means when would I keep the minus and get rid of the plus? Well, just the opposite. If this had been instead y is less than or equal to 3, let's just say that's not what it is, but if that's what it was, then I would get rid of the plus and I would keep the minus because I want y coordinates that start at 3 and then are less than that. So I'd be subtracting numbers from 3. So that's how you decide in the end whether you keep the positive or you keep the negative. What half of the parabola are you talking about? We are talking about the top half of the parabola when we're adding to 3. Again, if it had been the bottom, the opposite, okay? So that's our inverse. So the only little thing you got to catch at the end is, do I keep the plus or keep the minus? In this case, keep the plus and ditch the minus. All right, let's just do a quick extra question here right at the end. Let's determine f of 36 and then f inverse of, I'm going to change that number there because that's not going to match up. I've changed my numbers here. So let's make that 2,179. All right, so what's the point I'm trying to make here? Just reminding you about coordinates and inverses. This always messes people up. So let's start with our regular one, f of 36, right? Well, if I substitute 36 in the equation, I'm going to get 2 times 36 minus 3 squared plus 1. All right, so I'll spare you all the details. Long story short, you go 36 minus 3 is 33, square it, times by 2, add 1, you get 2,179. So that gives us the coordinates, right? When x is 36, that's the x coordinate. The y coordinate is 2,179. So therefore, if I said to you, hey, what's f inverse of 2,179? We could substitute that into this equation, right? We could go 2,179 minus 1 divided by 2, take the square root and add 3. And guess what we'll get out of it? We should get 36 out of it because it's the inverse. Because if we wrote this as points, when x is 2,179, y is 36, right? So I'm just reminding you, keep reminding you that it all goes back to the coordinates being inverted, okay? All right, so that's how you find an inverse algebraically. Make sure you try the work. Thanks for watching, and then check out the next lesson.